Hello, Pre-Calc Honors kids. This is Mrs. Orloff, and I hope you're all doing well. Today we're going to do the first lesson for 6.2, which is going to basically cover vector multiplication. These notes are trimmed back to make sure we get through the mandatory material to be successful in Calculus BC. So here we go. We can multiply vectors in two ways, and one of them is the dot product. So if we look below and we see the vector u, and we have u sub 1 and u sub 2, and then we have vector v, v sub 1 and v sub 2. So if we take u and multiply it by v, we take u sub 1 times u sub v plus u sub 2 times v sub 2. Please take a moment, pause the video, and read through the dot product properties. Okay, I'm assuming you have read through these properties, and I want to point out one of them. U times u equals, and it looks like the magnitude of u squared. So it should make sense to you if we took that magnitude of u and we square rooted u times u. Okay, we're going to work through this first example, and we're going to find each of the following. We're going to take the vector 3, 4 and multiply it by the vector 5, 2. And we're going to use the dot product to do this. It's pretty straightforward. So I'm going to start with those two horizontal components from each vector and multiply them together, and then add them to the two vertical components and add that to the two horizontal components. So we have 15 plus 8, which is 23. The next example, we're going to go ahead and take 3 times negative 4 and add it to 4 times 3. Now I look at the next two examples, and I'm no longer written as a component vector. I have that linear combination, and I'm still going to approach it the same way. I'm still going to think about this as this is u sub 1 and this is u sub 2, and I'll take the product, and then I'll add it to v sub 1, v sub 2. And I get 21. Okay, I'm going to recommend you pause the video at this time and try D on your own. Okay, I assumed you have taken the time to work out D on your own, and you will see that you have a product that equals 0. We are now going to go ahead and look at example 2. We're going to find the magnitude length of the vector negative 4, 3 using the dot product and confirm using another method. Okay, so if we use the dot product, I'm going to go ahead and think about this property up here. And I'm going to rewrite it though. I'm going to say the magnitude of u equals the square root of u times u. So we're going to go ahead and take the time to pause this video and set up that u times u. You can see that I wrote u times u below my original formula. And I'm going to go ahead and find the dot product. So negative 4 times negative 4 is 16, and I will add it to 3 times 3, which is 9. So u times u is 25, and if I follow this formula up here, I get the magnitude of u will equal the square root of 25, which is 5. I want you to take a moment, pause the video, and think of another method to confirm that. As you can see, my second method, I've placed the vector in the appropriate quadrant, and I've drawn a reference triangle. So I know that this length of this side of the triangle is 4, and this is 3, and by Pythagorean, I get this length of the hypotenuse to be 5, which is also the magnitude of the vector negative 4, 3. The next theorem we're going to work on gives us the formula for the angle between two vectors. Now, if this was a normal lesson in school, I would have you guys prove this theorem, using the law of cosine. So if you want, go ahead and see if you can try to figure that out. But the theorem of the angle theta, where theta is between 0 and 180 degrees inclusively, it gives us that angle between vectors u and v. It is related to the dot product in the following way. Cosine theta equals u dot v over the magnitude of u times the magnitude of v. And you can see me solving for theta there. This is not the only method for finding the angle between. We can always find the direction angles of the two vectors and do some manipulation, whether it's subtraction or whatever we might want to use. So we're going to go ahead and work through this example 3. We're going to find the angle between the pairs of vectors. So if I think about this and I think about the dot product between these two vectors, I'm going to find out that I have 3 times 5, which is 15, plus 4 times 2, which is 8. Then I'm going to have to go ahead and I'm going to have to find the magnitude of each vector. So pause the video and find the magnitude of each of the individual vectors. I have the magnitude of u equaling 5, and I have the magnitude of v equaling 29. So I can go ahead and place that information within my formula. And so now I have theta equals cosine inverse of 25 plus 8 all over 5 root 29. I want you to take a moment, go get your calculator, make sure it is in degree mode, and find this angle. If you didn't get this correct, I want you to take a moment and check my grouping symbols. Also make sure you're in the right mode, but theta should equal 31.329 degrees. Okay, so we still have in example 3, we have B and we have C. I want you to pause this video and work through just B, not C, and then we'll come back and we'll check your answers. Okay, in example B, we can see that theta equals cosine inverse of 0 over 5 times 5. You should not need a calculator to find out that that equals 90 degrees. Let's move on to C. We have our vectors in linear combination form. And so I'm going to work through, if I call this vector u and this one vector v, I'm going to go ahead and get the dot product of u dot v. And so I have u dot v equals 8 plus 18. Now I'm going to find the magnitude of u. So I have the square root of 4 plus 9, which is the square root of 13. The magnitude of v, which is, let's see, 16, square root, of 16 plus 36, which is the square root of 52. And so theta equals cosine inverse of 26 over 26. And so cosine inverse of 1 gives me 0 degrees. What will the dot product of two vectors be if the vectors are orthogonal, perpendicular, or what will it be if the vectors are parallel? I want you to pause the video, look at the examples above, and come up with some ideas. So orthogonal vectors would give us an angle between that will give us cosine 90 equaling 0. So the dot product would have to equal 0 for those vectors to be perpendicular. And if I end up with parallel vectors, I would have to think about that angle between giving us 0 degrees. So cosine of 0 degrees equals 1. So our dot product would have to be equal to 1. Okay, I'd like you to take a look at example 4, read through the direction, and see if you can figure out how to set this up. Please pause the video and take a moment to do this. The first thing I'm going to do is change that format of vector u and vector v. So I have to go back to my right triangle trig and think about cosine of pi over 6. And I realize that cosine of pi over 6 is root 3 over 2. So I'd have 2 times root 3 over 2 I. And then I'm going to think about sine of pi over 6. And sine of pi over 6 is 1/2. So I have root 3i plus 1j. I'm going to go ahead and do the same thing with vector v. Cosine of 2 pi over 3. So now I'm in quadrant 2, and that gives me a negative ratio for cosine. And so I will have negative 1/2. So I have negative 7/2 I. And then sine of 2 pi over 3, sine in quadrant 2 is positive. So I have 7 root 3 over 2j. So I'd like you to take a moment and go ahead and find the dot product between u and v. Okay, you can see my work over there in purple, and you can see that I have the dot product equaling 0. Therefore, vector u is perpendicular to vector v. There's more than one way to do this. We could take those angles and we can find the difference between the two and determine that that is 90 degrees. Let's move on to example 5. So, oops, sorry about that. If I look at example 5, I want you to find the angles between vectors u and v. So we must remember that we have this formula. This is one way that we can find the angles between. As always in mathematics, there's typically more than one way to do things. And so if you have a different method that's mathematically correct, feel free to use that. Okay? So this is one method for the angle between. And my second method would be to think about pi minus pi over 4, which equals 3 pi over 4, which is 135 degrees if I change that to degrees. Or, as I stated, we can use the formula. It's your choice. Okay, I want to give you one more example that is not typed in the worksheet. I want to think a little bit more of a thought-provoking question, as you know I like to do. So if vector u is 4, negative 3, and vector v is 7, k, and I'm telling you that they're orthogonal, then find k. Now, if you're understanding the concept, what makes two vectors perpendicular versus parallel, this shouldn't be too bad, because ultimately we should understand that u dot v would need to equal 0 for us to have perpendicular vectors. So I'm going to go ahead and I'm going to take 4 times 7 plus negative 3 times k, and I'm going to set that equal to 0. That's the hardest part of the problem, just understanding that concept, because from here we have an algebra 1 equation. And so we should get that k would equal 28 thirds. I hope you have a great day today. Get outside, breathe some fresh air, and hang in there, everyone.